from this computer. So where do I want you to be for the final project right now? November 4th, which is still ways away from right now, is your proposal in GitHub Lab. In other words, submitting stuff on GitHub. If I have to push that back, I will. But what I want you to do at the very least, I might rearrange it so that you put your proposal on GitHub. That's fine. And push that back until the 8th. That's fine if I have to do that. But what I want you to be doing is thinking about if you want to do this in a group or by yourself. If you want to do it in a group, who are you going to do it with? And what kind of project you want to do. There are example projects in this track, and I'll be going over more examples next week. PIG is your last formal homework of the semester. So I will be going over that, and the rest are basically just final project focused. So once we hit November, basically you're in the clear as terms of smaller projects. Then you're going to just have to start worrying about the larger projects. Again, this is where a group can really come in handy to keep each other accountable. All right, so let's go ahead and get started with the preparation for the exam on Thursday. Okay, more details can be found on this page over here in the email. Again, if need be, I will bring paper copies of the exam, of the solo exam, in case Murphy's Law applies and you can't use your laptop for some reason, okay? So, because I know how that works. So let's go through this. So first and foremost, stop sharing, share, screen one. Okay, first and foremost, I can assure you that there will be a question like this one on the exam, but let's go just briefly through these. All right, the string Howl's moving castle is a valid string. Why is it the problem that the character in the word howls isn't escaped? In other words, we've got, and if you're not sure why, because you're coming from a different language, remember, strings can be started by using a double quote or a single quote. And if you're starting with a single quote, then it's got to end with a single quote. If it's starting with a double quote, it's got to end with a double quote. But whatever you don't use, you can use the other one. Sorry, whatever you don't use, you can use that one inside, no problem. That's what it comes down to. What is the main difference between a dictionary and a list? A dictionary allows you to store arbitrary key value, arbitrary keys and values. Basically, you can completely make up what the indexes are, as opposed to being stuck with sequential indexes, right? If L is a list, what does the expression L : -1 do? This is extremely useful shorthand. It is shorthand for give me a copy of the list, but in reverse. So this gives you so this also works for strings, by the way. So if you take a collection and do this slice notation, : -1, it reverses it. Super useful. And how do we use the slice notation to get the last 3 characters of a string? Also super useful is the negative notation over here. From the last, so -3 is the last part of the string. So -1 is the last character, -2 is the last 2 characters, -3 is the last 3 characters of the string. So so the third from the end index up to the end and going through the end. And finally, how do you simulate a coin flip in Python? You use a random, basically there's a bunch of different ways to do that. You can create a list and say random.choice from like a true or false value or a H or tail value, or you could have generate a number between 0 and 1 and basically say if it's less than 50%, then it's one value, and if it's greater than 50%, it's the other value. You can generate a random number between 1 and, you can generate random numbers of 1 and 2. So you could do random.randint 1, 2, right? And if it's greater than 1, and if it's 1, it's this, it gives you a head, 2, it's a value. There's a lots of ways to give you a 50-50 split. Yes. For this exam, no. most of this will be on part 2 and part 3, which is these so these function kind of things. You can expect to be filling out a lot of functions. Well, not a lot. I'm going to figure out what's reasonable. I'm going to be writing it tonight and figure out what's reasonable, what is reasonable within a 50-minute time frame, you know? Okay. And again, for a coin that's slightly weighted in favor of heads, there's a random.random that generates a number between 0 and 1, you know, double float value. And again, if it's, you can use 0.55 and use an if else statement there. Again, I'm not going into heavy detail on that because those are less important for the exam. On the exam, I'm probably going to be asking a few bigger questions with rubrics attached like this one. So this one was an actual one asked when I was doing exams pre-COVID. So suppose we have a file called temperature.csv, okay? So for the sake of simplicity, I'm not necessarily going to give you, I might give you a file, but you don't need to run it. It's going to just be a file that's going to be a way of, if I give you a file, it's only going to serve as a purpose to confirm whether or not it works, okay? So don't write code to hard code the answer in based on what you see in the file, okay? The entire point is just like, I want to make sure you have, if I give you one, it's because I want you to have an easy way to check it, okay? Similarly with the functions, I give you example inputs and example outputs, right? If I give you this function, this is what gets returned. That way you can see what, you know, if you test the code, you have tests that show you whether it will be correct or not if you run it, okay? So suppose we have a file called temperature.csv. It contains the daily high and low temperatures in Philadelphia. It's composed of 3 fields per line containing a date, a high temperature, a low temperature. So the file will look something like, if you opened it up in your browser, it would look something like this, where we've got a comma separated values. That is too small. Let me go ahead and file, edit, views, come on, settings. Where are the settings? Oh, preferences, there. Okay, 36, let's crank that up by 50%. Okay, there we go. So your file is going to look something like this, okay? Okay. So the question is, write a program that calculates or prints the following: the day with the hottest high temperatures, the day with the coldest low temperature, and the average high temperature of the entire file. Okay, so for this one, this is essentially these two are find your minimum and find your maximum problems. And this one requires you to just average up the file. So what we can do here is that we can split this up into separate tasks. So the first thing we can do is to prac save as .py to give it fun. There we go. And yes, install the extension for Python, please. Boom. Okay. So we can do def read file, and this is going to give us our data. We can do this as a separate function, or we can, you know, read it all as outside. I like to read it, and I'm just going to simply say, given a file name. And so what we need to do is first read the data, and we're going to need to separate it out into 3 categories. Specifically, what we've got here is we want to separate it into our dates, our numbers, sorry, our highs and our lows. So let's make those. Dates is equal to boom. Dates is equal to list. Highs is equal to a list. and lows is equal to a list. Okay, and what I always like to define like what I need to return at the end, here. And then at the top, and then automatically at the bottom, put what I'm going to be returning. And one of the things that you can do in Python that I love that make this easier is that I can return multiple things. Technically, I'm returning one thing as a set, but then I'm unpacking it. So dates, highs, lows, boom. So I can return two, three things. And when if I were to call this read file, and I call it whatever, pass in whatever file name is, I can get all three values out: dates, highs, lows. It's very useful that you can do that in Python, right? So you can do that. The other way to do this is just to skip all this functionating, and you can just simply do it outside of a function, because however you do it, it works. I didn't specify that it had to be in a function for this one. So here, this is the file reading though. Open file name. Data is equal to open file name. You don't have to type in the CSV or anything because we're just assuming we're getting it here. And we'd be typing in whatever the file name was. So temperatures.csv. Open file name. Open file name. And we're going to open it in read mode. For a line in data. Date. Ooh, I'm doing a great job of misspelling things today. Absolutely on point there. So for each line in there, I'm just going to go through. We read a line and we're getting something like these comma separated values, right? We've got three fields, and they're going to be separated by commas. And it put in spaces automatically. Don't worry about those. It's just because of how LaTeX works but it's going to look like something like this. It'll be easier to see in your on your exam. So this is the way it looks. So what we need to do is we need to split this up into its fields. So fields is equal to, and again, I'm going to give you all this code, upload the video as soon as it's done. Fields is equal to line dot split on the comma, and that will split it up, and that's going to create a list with three elements in it. So dates, fairly straightforward. I'm just going to say dates dot append field. Assuming you can hit the right key, field 0. Highs dot append, and what I'm going to do, and now we want these to be numbers because I'm going to be comparing them against each other, so I'm going to go ahead and convert it into an int. You could do float as well. Doesn't really interfloat. It doesn't really matter. My example just had whole numbers. That's why I'm doing ints there, but floats works just as well. Int fields 1. And we don't need to convert the other because it's a date. We keep the slashes. And lows dot append fields 2. So doing this would be a good chunk of the credit of the problem. So now what we would do is, now that we've read it, let's go ahead and work on calculating the values. So def highest high, right? And this needs just two and we need two of these lists to deal with it. We need the dates, because the entire question is, we're not trying to figure out what the highest high is. We're trying to figure out what the day with the highest high is. So dates and highs. Okay. Okay, and then what we're going to say is, so we're going to need so highest day is going to be our answer. And for right now, so we could do a couple things here. We could do empty string. Or we could say, hey, the very first thing in the list is the highest temperature. They're both valid ways of doing that. Saying the first thing in the list is our initial starting position for the highest day. Similarly, highest temp is equal to highs 0. Just assume that the first thing is. The other way we can do it is that we can leave we don't have a date yet, so we could leave it blank. And then we just need some value that would immediately get replaced as the highest temperature. So we could do something like negative some big number, right? Because any temperature will be bigger than that temperature, right? So those are both valid approaches to do this. Make sense? So what we do is now just is our standard for loop, but I'm going to want to use the indexes to go through them so that I can map the dates to the highs. So for this, so we can do it like this. We could say for index in range len of days. That's one way to do this for loop. I'm sorry, dates or highs, doesn't matter. That's one way to do it. Another way to do it, which is the way I prefer, which is for index date in enumerate dates, and that iterates over both the index and the date at the same time. I love enumerate. It's such a great, useful feature built into Python. Sorry? Okay. There's probably a way to throw the third one in there as well, but let's see. Enumerate iterable, right? And so you can probably zip it up, but honestly, that will make it too complex. Let's go ahead and get the high temperature for both. So, or let's call it the daily temp. Daily temp is equal to, so the temperature for that day is equal to the highs, and we're going to just simply get it from that index, right? The same index that the day is at, right? So this would be index 0, so we'd get temp 0, the high 0. Index 2, boom. Sorry, index 1, get the one at index 1. Index 3, get highs 3. So 2. Blah. Okay. Highs. So we've got index date is equal to enumerate dates. Highs of index. So we get our 0th index, the first, the second, the third, the corresponding thing. And then what we ask is this: if highest temp is greater than, or we can do greater than or greater than equal. Both have their merits. Perfectly fine. So if our temperature is higher than, sorry, if daily temp is higher than the highest temp we've seen so far, well, that's the new highest temperature. And then highest day is equal to the current date. Yep. And then now that as we go through that, and then we return highest day. Doing the lows is pretty much exactly the same thing, only instead of taking in the highs, we take in the lows, and we'll just simply do a lot of renaming. Lowest day, the lowest temperature. Now we're just going to put in an absurdly hot temperature, right? Now we'll just put in an absurdly hot temperature because any temperature will be lower than that temperature. So for index and date, get the lows, get the low that is the same from the same index that our temperature's at. And if our daily temperature is lower than the lowest temp, then we just simply do the same thing. We update our lowest temperature. And now we also rename this function so that it actually works on the lowest low. Make sense so far? So to figure out the highest high, we just simply, and again, this is just a number I just randomly hit on the keyboard, but any number is going to be higher than this negative number, and any low temperature is going to be colder than this really big positive temperature. Okay. Alternatively, you could just simply grab the 0th index. Both are valid ways of doing this. And now the last thing is the average highs. Average highs is equal to, so that we just need to take in the highs. Now there's a couple different ways we can do this. So this is the average high temperature of the entire file. There's a couple different ways we can do this. In one line, we can solve this by doing sum of highs divided by the length of high. In other words, add up all the numbers. That's what sum does. Divided by however many numbers there were. That's how you calculate an average, right? One line solution right there. However, you know, during the stress of an exam, you may not remember how in the world do I do that? Like, how do I add, is there a function that adds up all the stuff? Is there a number that, is there something that tells me how many numbers I added? So if you want to do it manually, or need to do it manually, num temps is equal to, so the number of highs is equal to 0, sum of highs is equal to 0, and then what we just do is a for loop. For temp in highs. So for each of the temperatures we see in the high temperatures, we don't need to care about the index because we're just going through it and adding them. This is just simply an accumulator pattern. Num highs plus equals 1, sum highs, because we've seen one more temperature, that's why we add one more. We've seen one temperature, that's why we add 1 there. And then the sum of the highs is equal to the temperature that we currently are looking at. Return sum of highs divided by num of highs. In general, if you cannot figure out or remember how to open the file, okay, but you know what you're supposed to get from opening the file and parsing it, this is why it's useful to write functions, because you can go ahead and work on the other part of the problem and just work on getting credit for those parts of the problem, okay? The rubric will help you break it down into maybe suggestions of, if not functions, then parts of the functions to work on. It's an exam. Your code doesn't necessarily need to work. What it does need to do is show me that you understand the algorithm, or put your thoughts into an algorithm. If you don't know how to put those thoughts into an algorithm, but you've got, or into, if you don't know, if you've got the algorithm but don't know how to put it in Python, then give me that algorithm in the comments. And I do mean like an algorithm that kind of tells me, okay, these are the steps you have to go through. The more specific, the better. Okay. Next problem, which is for practice, is suppose we have some file named numbers.csv, which contains a bunch of numbers, 5 per line of text, separated by commas. So, and then sum up all the even numbers. Okay. We can do that in basically one function. So def read file and sum. Again, file name. What we're going to do here is data is equal to open file name at read, using read. So we're going to read it. For line in data, we're going to go ahead and read this line by line. Fields is equal to, so we've got a bunch of fields again, and we're going to split it up by the commas because it's comma separated. So line dot split, again with the commas. And then for n in field, one of the things we have to do in fields, so for each of those, first thing we need to do is we've got to convert that into an actual number, because again, whenever you're working with files, you're working with strings, so we convert it. If you forget that, that's like a minus, that and everything else looks like it would work. That's like a -1 or -2, depending on the context, depending on how many points there are. Okay. And then, so it's not like in a crater your grade is the point. So now we've got basic, and now we just need a running sum. Total is equal to 0. Return total down here as we add up stuff. And now int n here, and here what I'm doing is I'm being agnostic about the fact that there's 5 lines per, sorry, 5 fields, 5 numbers per line. It doesn't matter to me. I'm just simply going to take all of them. So convert it into an integer. If n mod 2, that's how I tell if something's even. If n mod 2 is equal to 0, if it's cleanly divisible by 2, total plus equals 0, because remember, not equals 0, total plus equals n, because remember, we're adding in all the even numbers together, right? So we go through, we add all the even numbers together, and that's it. Yes. Yes. I mean, as long as it's not like one of those ones that you have to install via, that you'd have to install via pip. So if they're built-in libraries to Python, yes. Okay. I mean, I suppose you could technically use the CSV library. That's not an unreasonable one. But like, if you're bringing NumPy into this, you're bringing a, you're bringing a nuke to a knife fight essentially. So let's see. What else have we got here? We've got, so let's go ahead and work on these method writing. So you're going to get probably one file with a big, nice, helpful rubric. Sorry, one file reading question with a helpful rubric about what you're supposed to do with it. It's going to be something like this, where you're splitting up fields and doing some numerical kind of basic numerical analysis on it. Like so something very similar to one of these two problems you got. Okay. The next, and the rest of the questions will probably be something along the lines of this. Here's a function. Given a function, here's a function, here's what it's supposed to do. Please write it and make sure they return things. It's important that they return things in this, by the way. Don't just print them out. I mean, you can as part of it, but you want to make sure it returns. So let's go ahead and start on this. So given a string that begins with un, so if the given string, if the given string starts with un, return the string without un in front. Otherwise, give me the string with un added to the front. You can assume that it's at least 3 characters long. That's not an assumption we need to worry about too much in Python because of slicing. But in Java, where I've gotten this from, when I used to do this in Java, that was an assumption. So for instance, untied becomes tied, unable should become able, and necessary should become unnecessary, right? You're just adding on in front of a word, or if it begins, basically you're kind of flipping the switch as to whether it's an unword or it's not an unword. So apple would become unapple, even though that's not really a word that makes sense. All right. And these should be, and the nice thing about these is that they're going to be fairly easy to test because you can test them on the things on these comments. And you can just simply, again, they're going to be not in a PDF form. They'll be on Canvas. So it's going to be super easy for you to just drop them in your editor. Okay. So on or on. So so we have 2 cases. Does it begin with un or does it not? So how do we know if it begins with un? So if the first 2 letters are un, how do I figure that out? There's 2 ways I can do this. And also it tells me that it's going to have at least 3 characters. So I don't have to worry about like going out of bounds. I can simply do if word 0 equals the U, and word 1 equals N. And that's then it starts with un, right? So in this case, what I'm going to do is I'm going to return it with that bit sliced off. Slices are the easiest way to do that, which is simply return word 2 to the end. 2 to the end. There's also, I mean, you can also use a slice over here. We could just simply as easily do if word zero up to, but not including 2. So, and we know how long it is. And the reason we do that, it goes up to, but doesn't include, is because you can tell how long it is by subtracting the end point. So you can take the end point and subtract the start point. That lets you know it's too long without having to do any funky math. So if that's equal to un, both of these are equally valid ways of doing it and would give you full credit for that half of it, right? Okay, what if it doesn't begin with that? Else, it needs to now start with on, which there's a few ways to do that, but I can just simply do return un plus the word. Just tack it on in front. String concatenation's your friend here. So there's a lot of, but again, you may have found an overcomplicated way to do this. If you did, does it work? Okay, great, you get credit. Okay, if it works, it works. So long as you're not like hard coding it. But again, we can kind of test this by saying, hey, let's go ahead and take that. So we take this over here, just from the comments. I go print over here, and then I run it. I said I run it. Yes, trust workspace and continue. There we go. Python file. Okay, and oh, it's tiny over there, so boo. Okay. Let me go ahead and it gives me tied. So give me 1 second. Preferences, settings, terminal. Terminal size. There we go. Font size 26. There we go. Now it's top. Now hopefully you should be able to see it says tied down here. And let me boost it up. It doesn't matter for me. 32. There you go. Now you can see it's tied. So you can just simply dump in these checks into here and verify for yourself that it's working. I'm not going to have anything like weird in here that's going to, you know, I'm not going to have any like cases like, aha, caught you. You didn't account for this because it wasn't in the test cases. I'm going to try to avoid that because that seems like a really jerk move. Again, so min-max difference. Given a list of integers, return the difference between the max and the minimum. You can assume the list will have 2 or more elements in this. So there's 2 ways to do this. Okay. We can use the built-in min and max function, which make this super easy, which is, again, let's see, it's the maximum minus the difference between the 2. So the max minus the min. If you do min minus max, whatever, okay, it's not going to be a big deal. But the one line solution is, you know, using built-in functions, max of numbers minus the min of numbers, and that can also be a 3-line solution by creating variables, of course, saying here's the biggest number is equal to maximum, smallest number is equal to minimum, right? That's one valid way to do this, all right? And so we can simply do we could test it on these and see like 100 minus negative 100 would be 200. 31 minus 15 should give us 16. 5 minus 1 is equal to 4, right? But suppose you completely blank and say, wait, Java doesn't have a min and max function easily accessible. It does. Or C doesn't, probably not. So I need to do this manually. Perfectly fine. Don't care. As long as if it works, it works. Biggest is equal to 0 is equal to, so I'm gonna use the first value. Biggest is equal to the first value. Smallest is equal to our first value. Don't care if we double check this, is fine. So we're just gonna set up our biggest and our smallest values. And when we're gonna figure out what they are, but we're gonna do biggest minus the smallest at the end, okay? Now we have to go out and figure out what the actual biggest and smallest is. But if you do this and say something like, here's the magic, you'll get like a couple points at least, it will at least show me that you understand something, okay? So for each num in numbers, right? If the num is greater than the biggest number, so if it's if it's bigger than the biggest number, that should be the new biggest number. And biggest just becomes a weirder looking weirder looking word the more I'm looking at it. I don't know why. Okay, else, and here we don't want to do an else because there's no need. And then if num is, you can do an elif, and that'll probably work as well. If the number is less than the smallest, or if it's smaller than the smallest, that should be our new smallest number. Okay. Print min max diff, and we'll go ahead and put this in. Ta-da. 200, right? Because the biggest thing in there was 100. The smallest thing in there was negative 100, right? Negative numbers are small. So they're weird like that. So 100 minus negative 100 is the same as 100 plus 100. So 200. Okay. Swap ends. Given a list of numbers, modify the list such that the first and last elements are swapped. You can assume that it has more than 2 in it. This one, again, is just making sure, do you understand indexes? So again, easy to get them in here just by copying this in. Not really a valid one-line solution. Aha, you can tell that one came from Java because it had Java comments. Okay, swap numbers. So now here's the thing. You can't just, so you don't need to return this one because we're changing the list. So that anything that affects the list from inside the function will perpetuate outside. But if you return it, it's a fine. It's not going to change a thing. Okay. Yeah, or rather, it's not going to matter in terms of your score. So the pitfall here is not using a temporary variable of some kind, because if you just simply do numbers, so the first number, we want to move the last number there, is equal to numbers, and there's 2 ways to refer to the last number. It's going to be at the last possible index, which is length of numbers minus 1. Or just much easier to refer to that as numbers -1 to get the last number, right? But now the first number that we have has been overridden. And so there's no way to get that and put it at the end. So here's where we use an extra variable, or we can use 2 extra variables, because for me, that makes it super straightforward and easy to read. Readability is wonderful. First is equal to numbers. So that's what I'm going to do. First is equal to number 0. Last is equal to numbers. And yeah, there's other efficient ways to do this, including the problem I gave you on the exam, on exam 1, which showed you how to swap two numbers by using addition. But that's the really only way to do it without, any variables, but whatever. This way works. So we've got our first number. We want to put it in the last index. At the end, numbers is equal to, so numbers -1, the last position. The end of it should have the first number. And the beginning of our list should get what was the last number. Make sense? So a lot of these are straightforward. Maybe not straightforward in their intent, maybe not necessarily in how to write them, but they are direct. I'm not trying to do too many tricks here. Okay, how's wildcat? Given a input word, return true if the word contains the string cat in it, but the middle cat can be any character. Yeah, that should be any string. So for instance, wildcat kitty is false. Tomcat is true because it's got CAT in it. And then C4T nip is equal to true because we've got C, any character T. So any character, so the middle A can be any character. So here what we're going to do, so really what we care about is that again, here we have the indexes that we're caring about. And this is one of those where I actually am starting to put in mild tricks that if you don't catch it, it's a few points off, because what we're going to worry about in this one is index out of bounds errors. Okay, and so if you get hit by that, that's going to penalize you partially. So there's a couple ways to do this. Of course, we can do it with slices. As you can tell, I really love slices in Python, but we're not going to do a slice this time. I'm going to go ahead and so here I'm going to return false at the end. I'm just going to assume false because I'm going to assume it doesn't most words don't have a C blank T in them. And then what I'm going to do is I'm going to do my for loop for index in, and here I'm going to do this way. We could also do enumerate, right? So this will go 0 up. So this will give us all the valid indexes. So here it would give us 0, 1, 2, 3, 4, 5. It would go up to, but wouldn't include the index 6. So then we have to ask ourselves a question. If word, the first thing we have to ask is if index, so if the letter at that index is equal to a C. And then we have two ways we can go there. You can either write an and, or you could do colon and do another if statement. Both are perfectly valid. Just depends on whether you prefer to stack your ands and if statements or just write them out. And word index. So this one after that, the next letter, the letter at index +1 can be anything, so I don't care. Then index +2, that has to be a T. The one 2 letters after it has to be a T. So this will work if you test it on cat or so it has wildcat print. So this is going to work on cats are great. It's going to be true. Or I think cats are great. But this is where, but it will fail on the example that I gave, which is Tomcat. It's not going to, or rather, it's not going to fail. It should, I'm surprised. Oh, yeah, it will work there. But, sorry, it will work there, my bad. But on Kitty, it's going to fail. Should have failed, actually. Oh, because of short circuiting, right? Okay. So I need, oh, here's an example. And there it will fail. And the reason for this one is because when we are looking, is because we went out of bounds. We saw C here, okay? And then we tried to look 2 letters to the right. There are no 2, there's no letter 2 from the right. So this is one of those minor issues, and I would try to put, if I have that, I'm going to try to put an example that would, you know, catch that. But that is a very, but that's what could happen there. Okay. So anytime where you're looking ahead, where you're going to be looking ahead, you want to subtract the amount that you're going to be looking ahead over here. That way I'd stop looking over. So I would look at CIT and then I'd stop looking, because once I get to this T, if there's no letters 2 ahead from here, then it's impossible for me to fulfill this condition. So I'm just going to go ahead and quit the for loop. So in other words, if your algorithm depends on something that's, you know, further ahead, you know, indexes up, then you just want to make sure you don't go out of bounds. The other way to make sure you don't go out of bounds, by the way, is of course, as I mentioned, to use slices, which is if word is equal to this, let's see, although that's a bit of a pain to do with slices, because it ends up looking like something like this. If index to index plus 3 is equal to, and 0 point on that is equal to C, and index to index plus 3, index 2 is equal to the T. Yeah, that looks horrible, doesn't it? Not easy to read. So in actuality, it's best to like use this. But if you miss that on the exam, it's not going to like crater your grade again. You'll get most of the credit. Okay. This is just one of those things I'll write down in the rubric. And you're not going to have as many problems as this exam has, by the way. You're going to, I just like giving a lot of questions so that you have a lot of chances to practice. So you'll notice that these problems I have, these came from Coding Bat. So that's a good source for you to look at. Okay. And I would highly recommend you taking a look at those. I'm going to skip that one for right now because I want to get to these other ones. And I also want to be able to get to the starting of the homework. Yeah, with question 17, having given it thought, I think I'm going to skip contents and dictionaries. I want to just focus on basically, do you know how to write functions? Do you know how to, basically I'm going to be focusing on 2 things. Can you write functions? And can you write, and can you read a file and work with a file? Those are going to be the main things. Like, yeah, well, for loops, yeah. So basically stuff from the last exam, I'm not going to really work too much on Turtle, too much, but yeah, I'll paste these on, I'll paste it in Discord. So let's go ahead and work on some of digits. So, and then once it gets to 3 o'clock, I'll take a look at Pig. Okay. So because most of the stuff again, past this is Monte Carlo stuff, and that's much more going to be what's on our 3rd exam. Okay. Oh, and last thing is the point breakdown for the exam. So it will be, last time it was 60-40, this time it will be 70-30. Okay. 70 on the solo portion, 30 on the group portion. So a bit more on you, but still a significant boost from being able to do it as a group. So so let's see. So I like this one, sum of digits. Given an integer, return the sums of the digits of this. So here we've got 1, 2, 3, 4. We add those together to be 1 plus 2 plus 3 plus 4. That gives us 10. 1 plus 0 plus 0 plus 0 is equal to 1. Negative 5, 8, 1 becomes 14. We don't care about the negative. We're just adding the digits together. Okay. So you get 5 plus 8 is 13 plus 1 is 14. So now this one has two. Now this one, unlike the other ones, has two drastically different ways of doing this one. Okay. Okay. Now we're going to be assuming that we're given an integer. Okay. Now there's two ways to do this. Solve it numerically using modulo, or to convert it to a string. So the instinctive solution, I'm sure for a lot of students who don't want to mess with math, is to convert it into a string. And, you know, I didn't specify that you had to do that, but I mean, like, sure, go ahead, you can do that. String. And so, yeah, we'll just convert it to a string. Okay. Because then we can iterate through those one at a time. There's also one issue, which is that we might have a negative number, which we can't really add. So if if the first character is a negative, then let's just chop it off. Num is equal to num1 to the n. And then if you forgot this is one of those minor points. So for digit in num, the key here is to recognize you cannot use a for loop over a integer. Okay, you have to do either math or you have to convert it into something you can do a for loop over. For digit in number, right? We need a total. It's equal to 0. If. So, and then we can assume we were told this being an integer, so we can convert all of them. So int total is equal to int. Sorry, total is equal to plus equals the digit. So take the digit, convert it to an int, add it to our total. So again, solution one works like this. Set up a running sum. Right, we've got our running sum over here, which we're going to need, and that's the only thing our two solutions are going to share. Your instinct, and if you look at this and your instinct is I need to use a for loop, the only thing that we can easily turn this into something that needs a for loop is by converting it into a string. Convert it into a string like this. If it's a negative number, that's going to mess up this algorithm. So we're going to cut off that negative sign and then simply go through, convert each into a digit. The other way to do this is to use modular arithmetic, which is while num is not equal to 0, and this will work for both our negative. This should work for both our negative numbers and our positive numbers. And if it doesn't work for negative numbers, guess what? You just simply convert that negative number to a positive number. In fact, I'm not so sure about that, so I'm going to simply say num is equal to. So let's see. Num is equal to. Does that still work in Python? Yes, it does. Great. It's a positive number now. So simply, I'm covering all my bases here. So while number is not equal to 0, total is equal to, we're going to add the last digit in. Mod by 10 to get the last digit. And then num is equal to num divided by 10 to toss out that last digit. And I used to do this. Now, this was way more important to me when I in semesters where I had more of a mathematical focus. But this was a question that I asked when this class was, when the intro class was explicitly for CS majors. This I'm less focused on because you're not all CS majors. In fact, I think most of you are not CS majors. So what I care about in this case is, can you solve the problem? So less questions like this one, more questions like, has wildcat, min max, un or un? Those are kind of the questions I would ask. All right, so I'm going to copy this, and I reset this computer, so I haven't fully put this in Discord yet, but I will drop it into Discord. Don't worry, and I'll upload the exam. So what I'm going to do now is I'm going to talk about the PIG assignment and get you started on this one. I also should mention, please do not cheat on the PIG assignment. I will catch you. Seriously, I will catch you if you cheat on the PIG assignment. It's just going to happen. Trust me. Because if just simply put, if you're the only one, if you check Chegg and think you're the only one in my class who's going to be checking Chegg, congratulations. I think you've discovered a variation of the prisoner's dilemma. So, okay, what is PIG though? So PIG is a multi-part homework. It is, I think, 8 parts. It's a very long document, but that's because I had ins and outs. But what PIG is that it's a dice roll. It's a chicken-based dice rolling game. Where I say chicken, it's like, that's the whole concept of two people coming towards each other, and the first one to go to dodge out of the way loses. That's chicken, right? So here the idea behind PIG is a dice game. Okay. You'll have 2 modes, one playing against a player, one playing against a computer using an algorithm that you're designing. But the idea here is that it's a game, you're trying to get 100 points, okay? Each player starts at 0, they try to get to 100. Every turn, you start with 1 6-sided die. Okay, you start with a 6-sided die and you roll it. You roll the die until your turn ends when one of 2 things happen. You say your turn is over, or you roll a 1. That's the way your turn ends. You either say, I'm done, or you roll the die and you roll the 1. So your score for the turn is determined as follows. If you roll a 1, you get no points for the turn. You basically rolling a 1 means no points, your turn instantly ends. 1s are bad. Otherwise, if you keep rolling, then your points will accumulate for the turn. So for instance, my turn could be I roll a 6, I roll a 4, I got 10 points, and I think that's enough for the turn. So I'm going to say hold and end my turn and pass it to the opponent. They might do a 2, a 4, a 6, which gives them a total of 12 points so far. And then they roll again and they roll a 1. Their turn ends. They scored no points, and now it's my turn again. Make sense? So basically, you can the Jeopardy part of this, the chicken part of this, is where you keep rolling the die and you go, okay, can I just eke out a bit more points, or am I going to pass it to the opponent? Or my opponent's a bit ahead of me. If I roll the die one more time, I'll probably get ahead of him. But do I want to risk it or bank my points for the turn? Okay, again, so holding banks your points for the turn. Once you've accumulated 100 points, you win. Now, again, rolling a 1 doesn't delete all your points, right? If I'm at 50 points and I roll a 6, so if I've got accumulated 60 points, and now this turn I roll a 6, a 2, and then I roll a 1, I'm still at 50 points. I just lost the turn. I don't lose all my points. Make sense? So the Monte Carlo part of this is going to come in part 2, which will figure out the probability of, part 2, part 3, and part 6. So part 1, the first thing we're going to do, and I'm going to do this in class right now, is we're going to simulate a single turn of pig. In other words, we're going to simulate a simulated turn where the player's rolling until a roll is until they roll 1, or until the turn total is greater than or equal to 20. This is a strategy that the computer is going to use for most of our examples, which we're going to call hold at 20. So the computer, right, they've got to make a decision. They can't make decisions on the fly. They have to have something pre-planned, right? So the computers, so when we play against the computer's plan is going to be, I'm going to try to get 20 points a turn. If I get 20 or more points, I'm going to stop. Otherwise, I'm just going to keep rolling. So this is the output of the function that we're going to write. So basically, you don't have to make any choices. You just run this, and it's going to simulate the computer rolling this. Save. Pig.py. Good progress on this one so far. Okay, def. And I called this, and I'm going to call this autopig. Okay. So again, we make no decisions here. We just simply have our total for the turn, starts out at 0. And we are going to need to import random. And again, I'll drop this into Discord as well. Oh, and send it out. Or rather, I'll post the video to this as well and drop it in Discord. Import random. We're going to need to use the random to roll the dice. And we're going to only be rolling a d6. So we're going to do that so often that I'm just going to create a function right here called roll. Okay. And that is going to return random.randint. And again, random numbers are the only exception where it's inclusive, 1 through 6. Okay. So, let's see. So what we're going to do here is we're going to do a while loop, because we can't do a for loop because for loops are determinate. You need to know how many times you're going to roll. So let's call it, I'm going to call this roll d6 because otherwise it's going to be, no, I'll just call it roll. So we're going to always roll a dice first. Result is equal to, let's see. No, I can do it like this. Result is equal to 0 while result is not equal to, no, let's see. So this is the issue with these things. It's all about fence posting. Basically figuring out where you're going to do this. So I'm going to go ahead and just because of time, I'm going to be straightforward about it. We're always going to roll at least 1 die. So, while result is equal to 0. While result is not equal to 1, and total is less than 20. Actually, even easier. Boom. Result is equal to, so while the total is less than 20. So we're going to roll we're going to say result is equal to roll. So we're going to roll the die. If result is equal to 1. Yep. Yeah, I'm going to avoid using a break. We could use I was thinking about using a break to get out of this, but I'm going to avoid that. Well, done is equal to false. So while total is less than 20 and not done. So if we roll a 1, our total score is going to drop up instantly to 0. Done is equal to true, and that will end the loop. Otherwise, we rolled a number that's not that, right? And we're going to do total plus equals roll. And then one more if over here. If, nope, we don't need to do another if because, well, it's less than 20. So if we go above 20, that will counteract and it will no longer be true. And now for the output over here, it wants us to show us each of the rolls and then display the turn total. So print roll colon. So roll and result. And then outside of the loop, we will print the turn total. Comma and total. There we go. And then I will call AutoPig to test it. Okay, and so we see here that we rolled a 3, a 2, a 6, and a 23. Sorry, 3, a 2, a 6. Interesting. Roll plus total equals the result. I was re-rolling the die. So we rolled a 1 instantly and didn't get anything for the turn. Rolled a 1 instantly, didn't get anything for the turn. Rolled a 4, 3 2s, so 10, and then another 10, and we landed on 20 and we're done. Rolled a 1 again, 5 2 1, bam, 0. So that's our first function here. We're we don't need to return anything here, I don't think. I mean, we could return the total. That might be useful later on. But now let's go to the next part, which is the Monte Carlo approximations. Simulate a given number of hold at 20 turns and report the estimated probabilities of the possible scoring outcomes. So in other words, we're going to ask them to how many times they want to play how many times they want to automate a turn. Okay, how many times do they want to simulate a turn? And since we're going to hold at 20, there's 6 possibilities, 6 outcomes, right? There's the outcome that they get nothing, right? They rolled a 1. And then there's the chance we landed on 20, and then a chance of each of the numbers above that, right? So getting to 20 or 21, then 22, then 23, then 24, then 25. Make sense to everybody? So this is where the Monte Carlo approximation comes in. Def. Enter a single positive integer yielding the number of Okay, so I'm just going to actually take that as a function to make it easy to test. So I take it as an input easy to test, and I'll ask outside that function. That will make it easier. Okay, def hold at 20. Okay, and trials. Right, so see how this is our Monte Carlo approximation that I was talking about last time. Okay, now here's the thing. I've got this handy dandy AutoPig function right here that I've already written. It's basically doing everything we need. It's doing this strategy that I'm trying. So I can totally take this and just throw this in a for loop. See, why doesn't it not like the auto pick then? Oh, because I've indented here. So let's see. Here I'm going to just create a dictionary. Outcomes is equal to 0, 0, 0, 20, 20, 0, comma 21, 0. I mean, I could let it generate automatically, but honestly, I could let it generate automatically. So yeah, actually, I'll do that for right now. So I'll just simply do outcomes is equal to 0 is equal to a dictionary. It's easiest to store our outcomes there, and then for in range trials. Okay, we're just going to say, hey, if autopig in, so let's see, actually turn total is equal to autopig if turn total in outcomes. So if we've seen that turn total before, outcomes of that turn total, increment the number of times I've seen this. Otherwise, I've seen that outcome once. Make sense? So what I do is that I'm simulating this this autopig a bunch of times. It's going to give me its total back. And if I've seen that total before, then great, I've seen it one more time. If I haven't seen this outcome before, then I set the number of times I've seen that outcome to 1. Now what I need to do is print this out nicely. And the way I'm going to do that is for outcomes for score in outcomes. So for each score we got, so for each turn total, you can call it whatever we want. For each turn total in our outcomes, we're going to print the what that turn total was, and then not how many times we saw it, but how many times, but the percentage that it took up, which would be the number of times I saw it divided by the total number of rolls we did. Hold at 20. Try, oh, and let's do this 10,000 times. And so we see here that we got, okay, that we got all the different outcomes, they're just out of order. So we could do two things. We could do sorted over here to sort those outcomes. Makes it nice and easy to do. Or we could just pre-program those outcomes in. Okay. So does this make sense to everybody here? I don't want to move on to the next one, even though we don't have that much time, any time left really. I don't want to move on to the next one unless people understand what's going on over here for the second one. Because the third one, I might have to come back for that. The third one the fourth one isn't dependent on you doing the third one. The third one is an extension of the second problem. As with the previous exercise, but allow the user to specify the hold value. In other words, instead of the computer trying to go and do hold at 20, right? Instead of them trying to do hold at 20 as their strategy, we're letting them choose that. So hold at X. So what is the probability of reaching 100 in a single turn if you allow the CPU to hold at 100? So in other words, the CPU just goes for broke, where it just tries to win the game in one shot. What is the probability that the computer will win the game in one shot, just rolling and hoping it doesn't hit a single one? And the answer is it should be somewhere around 1% for your output. But what you'll do there is actually straightforward. What we'll do is that we'll take this AutoPig, and maybe I'll either modify it, or I can just call it AutoPig X, where it's gonna where we're gonna specify a hold value for that problem. And then rather than saying, well, total is less than 20, which is what our hold at 20 is, we're letting the user specify what that is. While it's less than the hold value. So while it's less than 50, while it's less than 100, while it's less than 10, whatever we want. And then we just use that to complete that problem. So I've given you 2.5 of the 8 problems right here. Okay, but the idea here is that you can use each of these to build up them. Problem 6 is basically saying, okay, here's your current score, roll until you either hit 20 in a turn, or until your score is greater than 100. Sorry, is 100 or greater. So roll until you hit the goal, or the turn target, or you win. Here, basically play a solitaire game. In other words, instead of playing against the computer, you're just doing a game by yourself. And that leads into number 6, which asks you, what is the average number of turns it would take a player to win using that strategy? Okay. Take care. Yeah. Sorry, right on. No, you don't have to write files. Just needing files.
Okay. Also, can you like know any estimate? I know you.
Maybe 5, 4 or 5, not that many.
All right. Okay.
The bigger the question is, the more discrete parts I break it into, so that I can have an easy way of saying, okay, you did this part versus that part. Yes, Michael, what's up?
Hi, I just had 2 questions.
Mhm.
So for the first question, are you gonna post like the code from today when you're going over the practice
Yes,
exam?
I'm
Okay.
gonna try to get it. I'm gonna get I neglected to install Discord on my computer after I reset it. So I'm gonna, after class is over, I'm gonna install Discord and try to drop it in there. I'm also gonna
Okay,
upload
great.
this lecture.
And the second question is, are you gonna post the code from the pig when you're
Yes,
going over that in class as
thing.
well?
Yep,
Okay.
totally.
Thank you so much.
Okay. And oh. Mhm. So yeah, if you can't move your exams, we can also schedule, I don't like the idea of a student taking 3 exams in one day. So if you can't get your professors to move, let me know and we can arrange for you to take your exam on a separate day. Yeah, we can do that. Just send me an email to confirm.
Can I demo?
And don't really have time for demos today.
No,
Okay,
Can I just ask one quick question then?
yeah,
So I'm using VS Code and
sorry.
sometimes it won't run. Okay, so basically,
Sometimes you have to like tell it that it's a okay place to run it. I'm not super familiar with VS Code. I've used it,
oh really?
yeah,
Okay,
it's not,
but basically it won't run as it won't run as Python sometimes, and I was wondering if you knew how to change the language terminal.
over here, if it's not a Python, you select down, if it's not identifying as Python, you select right down here.
Okay, perfect.
And that changes and that will change what the language is, and then you can even change the interpreter that's being used down here.
Okay, perfect. Thank you so much.
Okay, yes, I see a hand up over here.
Yeah. So, Professor, I tested positive for COVID last week, and I'm not sure if I'm gonna be like available to take the exam on Thursday,
That
depending on
makes
how I
sense.
test.
No, don't. If you're positive for COVID right
Like,
now, I would not.
You know how the CDC, you know how the guidelines are like after 5 days your quarantine is up
Mhm.
and stuff. Like,
Look, follow the
Like-
CDC guidelines, but if you're also not feeling well, then don't come and we can just simply arrange
Well-
for a different day.
well, that's the thing. My quarantine is gonna be up by tomorrow, and I do feel a lot better. But I just like want to gauge what you
Yeah, I
think.
would prefer that you'd spend some more time. That's my preference, but
Yeah, I definitely want to follow what you prefer. Although if I do stay home, what am I gonna do about the test?
you arrange with take it with the TA and your group score will be equal to your exam score.
Okay.
In other words,
Alright,
you just
thanks.
use your solo portion on it. So,
Okay.
but
Thank
again, if you're feeling fine and you're testing negative, then, it's your call. If you're not feeling well, if you wake up and you're not feeling well, or you test positive, then don't come.
I feel good. I just wanted to see what you thought. And
Mhm.
I don't know how long I'm gonna test positive for. Like I've heard you can test positive for a while after
Hmm.
initially testing positive, you know?
I'd follow the CDC guidelines as well as the school guidelines, okay? Also make sure that,
Okay.
I think you're also supposed to contact, I'm not sure if you're still supposed to contact for contact tracing, I don't remember that. Or let the school know for contact tracing. But,
Okay, yeah. I'll definitely play it by ear and
Okay.
test myself
yeah,
more.
again, follow the guidelines.
Yeah, for sure. All
Okay.
right, thank you.
I don't know what the guidelines are off the top of my head. That's the things I double check, but, let me just see.
I think it's after you test positive, you quarantine for 5 days, and then after your symptoms go away, you wear a mask for another 5 days. And then once you get to negative tests.
Okay, I tested positive. Stay at home and isolate for, okay. They do not have symptoms, so regardless of whether I'm vaccinated, stay home and isolate for at least 5 days. And isolation after at least 5 full days after your positive test. That's
Yeah,
I would-
today's the 5th day.
Yeah. It says, and isolation at least 5 full days after your positive test, so.
Okay.
So I would double check with Temple
Mhm.
for that. Again, but that's what the linked back says, okay?
Okay, yeah. Also, by the way, one more thing. I did
Mm-hmm.
send you an email about well, have you looked at that Olympic rings lab yet?
Pretty sure I did. Okay.
You
I'll
did?
check it off. Okay.
Okay. All right,
Oh,
thank you, Professor.
okay. Yeah, I looked at it. It may not have gone through. I'll take care of that now. Okay,
All right. Have a good day.
all right.
I just had a question about whether you received my email about my job at Vector, I believe.
Yeah, didn't I reply to it?
I believe you did, and yeah, you replied to it, and you said that I have to get in contact with my TA.
Yeah, that's
So-
no problem. Just since it's at the same day as the exam, just whatever.
Okay, so like, what would be like the time frame? Do I discuss that with the TA?